thank you for coming to BalCCon2k16. Hope you're enjoying. At the moment, we're going to hear a lecture about contemporary web server configuration. So today's web applications are secure, but they need to be sensible and modular in their configurations. So Martin and MacLemon will talk about configuring Apache to meet those configurations. So if you have any questions, you can ask at the end of the lectures, and enjoy. Thank you.
Thanks so much. If we're quick enough, we get to Nginx as well.
So he's MacLemon.
This is Martin. Yeah, web servers. They talk a lot of protocols these days. You all have heard of those. There's, of course, the good old HTTP, which started in 1991. Is there somebody born after 91 in this room? Usually there is. Okay. So this is history lesson for you. 1991, in the movie theaters, there was The Addams Family and Silence of the Lambs, if you still remember those. Of course, this was HTTP 0.9. A little later, in 96, HTTP 1.0 followed. Was the first RFC and IETF specified version of it, and
the movie in the cinemas back then was Independence Day, the first one. So.
And Train Spotting. So yeah, still in use. Another protocol that came out that year was SSL v3,
and we're still all using that one, right?
Yeah, that's the Train Spotting part. And in 1991 we got HTTP 1.1.
RFC 2616.
Yeah. Over 170 pages, so it became much larger and tried to fix a few of the shortcomings of HTTP 1.0, some of which worked, some not so much. There was a movie in the cinemas back then, but we do not talk about, since the first rule is to not talk about that movie, and the second rule is to not talk about that movie.
And there's also was some sort of Star Wars fan fiction going on in the cinemas back then.
We will talk about that as well, yeah.
But there was also another protocol released in 1999, which was...
Anyone? Ideas?
This is an interactive talk, sorry for that. We didn't warn you. That's probably, we don't have any chocolate to give away. That's
that's the problem. Yeah. So it was TLS 1.0. And, yep.
Yes, it's that old.
It's that old. Yeah. It brought one interesting addition, which is server name indication. So you actually could host multiple HTTPS websites on a single IP with TLS 1.0 back in '99. So why did we start with all the other crap?
Then, of course, there was TLS 1.1 back in
2006.
2006, sorry. Yeah. I'm still tired from yesterday's party. Sorry for that. Some modern cryptography was added, and some problems that were introduced with 1.0 were some sort of fixed.
Sort of fixed. Yeah, the real fix came in 2008 with TLS 1.2, which added authenticated encryption with associated data, namely AES-GCM, Galois counter mode. And of course fixed some other bugs in TLS 1.1. At this moment, TLS 1.2 is the only cryptographically and academically secure version we would like to use. And it's picking up. So recent TLS reports from SSL Labs said it's around 80% of web servers now support TLS 1.2. So this is we're on a good track on that.
Things will get interesting with TLS 1.3. That's going to be a lot of fun in the next year.
Yeah.
But back from cryptography to the more basic HTTP protocol, there of course were a few problems with HTTP. So Google in 2009 went on a limb and introduced the Speedy protocol to fix a few of those HTTP issues, make the web faster, basically.
Google tried to run on their own and skip IETF for a moment, implemented Speedy in their Chrome browser suite, and other browser vendors followed suit and implemented that protocol as well. Main differences are that Speedy is a binary protocol and not a text-based protocol anymore. This brought a lot of speed.
And also the pipelining they claimed to work in HTTP 1.1 actually worked in Speedy for the first time.
Yeah.
more or less.
And important, Speedy was based on HTTPS, meaning you could only use it with TLS and was mandatory. And this was the first time they actually managed to get an HTTPS site to be faster than plain text HTTP. So this was a very interesting observation for many of us. Of course, skipping IETF on the internet is not the best idea. And IETF took over in 2012 based on Speedy 2. They started a specification for HTTP 2.
So basically, wherever you see Speedy right now, it's in the phase of it's phasing out, it's getting deprecated. So HTTP 2 is actually the way to go. Actually, and a lot of stuff that didn't work with HTTP actually works with HTTP 2. So we have header compression, header handling is a lot better. The encryption part, it didn't take over from Speedy. So as MacLemon said, the Speedy required encryption. With HTTP, the encryption is sort of optional. The only client, let's call it that, the only client that supports HTTP through an unencrypted connection is curl for debugging purposes. All other implementations require
Encryption.
encryption.
In theory, you got a spec that says HTTP 2 without encryption is possible, but nobody implements it. So in reality, you have to use TLS, which is a good thing, I think. And with the header compressions, of course, Speedy had some problems using gzip there. This was fixed by using a special HPEG compression algorithm in HTTP 2, which knows about headers and knows about sensitive headers like cookies, and it won't compress cookie headers. So we're not running into problems with leaking data about cookies there.
What else do we have? Yeah. So HTTP by now is implemented in all major browsers. So we got support in Firefox from version 36 on. Google Chrome 40 started supporting HTTP 2. Safari 9 surprisingly supported it, and even Microsoft with Windows 10 and Internet Explorer supports it by now. So.
Yeah, if you're in a reasonably updated browser version, your browser already does support HTTP 2.
And we will show you later on how to enable HTTP 2 in the server side. So basically, you can turn it on, and it will probably work for most of your users.
Yeah. Of course, why should you implement modern TLS and HTTP 2 on your website? Of course, either you have a completely new site, then please start developing with HTTPS from the start in HTTP 2. You'll save a lot of work in the migration process afterwards. If you have a HTTP website that's already live and you want to go to HTTPS and HTTP 2, you probably have a lot of work in front of you. Maybe
but it's manageable. We have the actual example of a major Austrian news site that did the migration within, I think, 1 or 2 weeks. The hard code, technical stuff, and they're now testing it and rolling it out. So it's not a month-long project. It's probably faster than finishing an airport in Germany or something like that.
Yeah. So actually, the technical implementation is usually pretty fast. It may take you 1.5 years to convince management. That's a downside.
And if you have ads on your site, that's
And this also works with governmental IT web pages. There it takes even longer, but it works. You can actually get to those points. Of course, if your website already supports HTTPS or is even HTTPS only, just switch it on, and it's unlikely that you have any drawbacks from HTTP 2.
So what are your motivations to run through HTTPS and implement HTTP 2? Well,
2016 should be enough.
But also, of course, there's a lot of stuff going on the client browser side. Come in, there's still a few seats left. Well, you're already sitting on the floor. So a lot of browser manufacturers are actually closing down API access through HTTP connections. So if you access a website through HTTP, you won't get JavaScript camera access or anything else. Microphones,
gyroscope, meaning location and positioning data will be locked down. And this is going to get more and more in Chrome. If you're on the Chrome Canary 55 version for testing purposes, that will actually call out an HTTP plain text connection with a big red not secure label. So if you're not on HTTPS yet, you might want to go ahead
and you probably want to do that till the end of the year. They said they come out with the normal version of Chrome beginning of next year. So beginning of next year, if you have an HTTP site, the Chrome will tell you this is an insecure site, and and you will get a lot of tickets and user calls. So we don't want that.
Yeah. Of course, there's other interesting things going on the internet with plain text connections. You can easily manipulate them, inject advertising, and other funny things. Some websites actually come with a lot of advertising and tracking stuff already pre-built by the authors.
That's the stuff the website makers actually added on purpose. So that would be the good ads.
Yeah, that's 14 trackers on a single website. That's San Francisco Gate. You have heard of it or you haven't, it doesn't matter. It's 14 trackers. If you're on an interesting ISP connection that probably not their only business model is being
internet provider.
Being an ISP and providing internet connection, you might end up with some more trackers. So that's 65 trackers. Of course, somebody else is making business on your website now and probably tracking users in ways you maybe don't like that. And they can, of course, manipulate your website in any way they like.
Of course, there's always the argument, but HTTPS is so slow and it makes my pages load slower, and my Raspberry Pi servers are actually getting overwhelmed with the traffic, and I would have to buy a second Pi or have to upgrade to the newest version, and I don't want to do that. There's also an argument for that.
HTTPS with HTTP2 is actually really measurably faster than a plain text connection. Of course, you have the initial delay for TLS handshake, but everything else beyond that point, especially if you're on a high latency connection like a GSM connection or a satellite link, your mobile phone users will love you for switching on HTTP2 because every subsequent call, and especially if you're running AJAX heavy connections with a lot of requests going back and forth, your site will really benefit from HTTP2, so it will get faster.
And with contemporary hardware, all the encryption stuff is done by hardware, so it's not really a performance issue anymore.
Yeah.
So how do you start off implementing proper configuration?
Well, you use a famous Austrian band from the 70s and 80s, Status Quo. And of course, you got to capture what is already live on your sites. You surely have heard of SSLLabs.com. Do you know somebody who has not yet heard of SSLLabs.com?
I do.
You have not heard of it? Okay, I'll give you a really brief wrap-up of what this site is for. You go to SSLLabs.com, you enter the URL of a website. This is actually the Hungarian camp we recently visited. Awesome event. You should go there. Just let it test. It runs for a minute or two, and we give you a report. This is the executive summary part.
Print it out on a laser printer, put it in front of the senior staff.
Yeah, preferably in color. If everything's green, that is fine. You'll get a raise.
You get a lot of additional information. You get all the cipher suites. You get all the handshake information, protocol information, all the things you want to know about the site.
So this is the executive summary. If management does understand this, so will your customers and users.
You will probably have to explain to them that this is the American school grading
US English
system.
or UK English. So it's like grades from A to F. Of course, you get a lot of information about the certificate information, revocation status, which of course does not work. The whole certificate chain is displayed, or if there are any issues with the chain, like unsorted certificates or getting the wrong way. Of course, the protocol support with TLS versions that you support. There's the very simple to remember TLS traffic light we use. You should be on TLS 1.2 these days, of course, with TLS 1.3 upcoming probably early next year already. TLS 1.1 and 1.0, please only use them for legacy backward compatibility, and if anything says SSL version something, skip it, turning off. In 1996, where SSL v3 came out, the Austrian hit parade charts.
Worldwide. I think it was worldwide.
Yeah, it was Los del Rio with Macarena, and you probably don't want to do the Macarena on your web server anymore. And the other ones are not a lot better. It's Mambo number 5, Wish You Were Here. Yeah. So TLS 1.2, that was all summer long from Kid Rock. Probably better. And yeah, oh, Germany was One Republic. That's nice. Okay, the important stuff, the cipher suites your website supports. Of course, your web server should enforce these cipher suites and not let the client pick something. You get a very handy connection handshake simulation, which tells you, oh, this old browser will not be able to connect anymore.
My Windows 95 with Internet Explorer 5.5 can't connect to my website. Oh my God.
Yeah, it's probably better that way. So if there's a red line saying this client cannot handshake, it's probably for the better. And of course, there are no Java browsers, so it doesn't matter if machine to machine, that might be a different story. You have to look into that.
But that gets you into Java territory, and we don't go there.
We don't go there.
No.
Nothing good happens there.
Nope.
Of course, for TLS, you need ALPN or NPN extensions to TLS, so you need a fairly recent OpenSSL version, 102, or LibreSSL is also fine. And you get other nice thingies. They are highlighted in green on the report. If the green things are good, that's fine. And if you leak some metadata about your TLS version, about your OpenSSL ancient release, PHP, Perl, something, of course, we have turned that off.
The nice thing about the site is that it not only works on one server, but it also works on a whole cluster of servers and gives you a report on all members of the cluster. So this is and even if you have several names and if you have IP addresses and legacy IP addresses, it will all handle that for you.
Yeah, and this shows you have a consistent configuration across your servers and across the protocols. Of course, this does not have to be the same as well. So this is also a consistent server configuration across the whole cluster.
So consistency is good.
Yeah, this is the whole cluster fuck. They have actually improved. So they've gone to a consistent B by now. There's room for improvement, of course. What would be the worst report result you could get? Show of hands, any ideas? What could be the worst thing you can...
Shout it out.
Letters?
In letters, yeah, A to F. It's F, okay. Anything worse you can imagine?
Think outside the box. Think
Plain tag? Getting closer. There's no P value, but getting closer. Yeah, no such socket on 443.
T? No, there's actually something worse than T.
Yeah. This is like, oh, sorry, HTTPS port's closed. There is no secure website. And to be honest, OpenBSD, they had to implement TLS on the HTTPD on their own web server, and since they're really good at dogfooding their own stuff, they did this and they did a good job by now. So kudos to the OpenBSD project. They have a fundraiser at the moment. So if you use something from OpenBSD like SSH, go and donate, or have some company do a donation. We really need the OpenBSD project.
And there will be a talk on SSH on Sunday.
Yeah, of course. We already heard the T, which is a trust issue. That just means the checker can validate your certificate.
This is from an Austrian governmental server with trust issues.
Of course, you might not trust your own government for good reasons. There's also some other warnings you might get. So if your report looks like this,
you should take a closer look.
You should take a closer look, of course.
In this case, it was expired certificates.
Yeah, an expired certificate that had been expired for over 7 years.
Details.
You can extrapolate the patch level of that machine from there. Of course,
that would be interesting. No.
So if there's really bad things on your configuration, you'll get a really noticeable red line in the report. So this helps to find out what you need to fix.
So in order to get a proper, secure web server setup, you want to check your TLS setup, your TLS configuration. Yeah. We will show you in a minute or two how to do that. Any additional ideas on what you should do in order to secure your web server setup, apart from hardening the machine and the usual stuff?
And using TLS.
TLS, apart from using TLS.
What?
Shutting it down. Valid?
Yeah.
Valid
yep.
option. Shutting it down, yeah.
Marketing might not like that solution.
And we will start with the mail servers first and the web servers come after that. But
I like the idea with
yes.
Serving open directories is not serving sensitive files.
Yeah, that's going more into the content area.
We don't care about content. We're just managing the servers. No.
Not releasing version numbers and stuff like that.
Yeah. Not releasing version numbers.
Yeah.
Install everything unneeded.
Yeah, that's
Yeah,
server
that's
hardening.
basic
Yeah.
hardening stuff,
Yeah.
of course,
Yeah.
that's a good thing. Remove everything you don't need.
Unplugging, shutting it down.
Yeah.
How about an expensive certificate?
If you got the money.
If you like. Heard of these?
What?
HTTP response headers? Some servers deliver them. So we heard.
Yeah.
Sometimes the headers these days are more than the actual payload of your 1 pixel transparent tracking GIF by a factor of like 20. And they're delivered with every response.
HSTS or CSP stapling, things like that. HSTS. HSTS.
Yeah, exactly.
yeah,
We'll get into that territory. You're in a good track. I'm glad you haven't fallen asleep yet. So there's a bunch of security relevant HTTP headers you can tell your web server to send.
Which of course requires your browser to understand and implement them correctly. But if you don't send them, there's no chance for the browser to actually help improve your security.
Yeah. So if you already know SSL Labs, there's securityheaders.io, which looks strangely familiar. You just enter the website, you click on test.
You get a report.
You get a report. There's a difference between testing HTTP and HTTPS here, because you might redirect and upgrade your clients to a secure connection, which you, of course, should do. This tells me, okay, this is redirecting. Nothing to see here. There's no headers set on the HTTP connection. You could do that. And you'll end up with a quite nicely implemented header setup here. There's a few headers you can set on HTTP and HTTPS. It's those 3.
That's X-frame options, content type options, and the XSS protection. These are all settings you can, correct me if I'm wrong, but these you can all set without breaking or shooting yourself in the foot too badly. There are a few options we will get into a little bit later on, but these are basically safe.
With X-frame options, you basically tell the browser how to handle iframes and stuff. With most websites, you can basically say deny. With some applications, you can tell it to go same origin, so it only loads iframes from your own server. And with the other ones,
content type, you basically tell the browser, don't try to interpret, to check, if I'm sending a MIME header of JPEG, don't try to check out if there's actually JavaScript delivered and execute that JavaScript. Don't do that.
So you tell the browser to no sniff, because some browsers are really curious about what they get. You send a JPEG picture, you send it a JPEG MIME type. The browser says, well, this is JavaScript, and I can do JavaScript, and I'll run it now. Isn't it awesome? So the browser just outsmarted itself, and you had a successful attack on that website and on that user. If you tell it to no sniff, it will not sniff glue that your web browser sends. And with the cross-site scripting protection, some browsers actually do that, namely Internet Explorer, Chrome, and actually Safari, which is unexpected.
How did that happen?
Yeah. Of course, there's no C defaults on the interwebs, and you'd have to actually tell it to block cross-site scripting attacks with their own detection. Works more or less. There's not a lot of potential to get any side effects. Of course, you get from that report all the headers your website sends, with all the server stuff leaking information, and also a lot of information what these headers actually mean, what they can be used for, and what values are possible to use.
And of course, if you're a sysadministrator, you usually don't want to use one of those fancy GUI browser thingies and all that color stuff and so on. So
yeah, before we get into not leaving the comfort of your terminal, there's other headers that you can use. There's a bunch.
He moved the slides around. Sorry.
Don't tell anyone. Of course, there's the rather complex thingy. It's called content security policy, where your web server can tell a browser where to load content from and where not to do that. That thing actually gives you enough rope to shoot yourself into the foot, and if you didn't know rope could do that, you should have read the man page. It's awesome to implement content security policy, but it needs a lot of testing. And
if you don't like your developers, you just turn it on?
Yeah, it's funny to see marketing find out that their remotely loaded Google JavaScript analytics thingy has not been working for 6 months.
Or that the fonts suddenly don't render,
And the web page actually is pretty blank because they forgot about a font fallback in their styling. A lot of fun to be had with content security policy. They can be a little tedious to generate, so there's a convenient generator for that. You just click together what you like to have, and you'll get a nice string that you can copy paste into your Webserver configuration.
But
That's
please,
pretty convenient.
but please do test this thing before you turn it into production.
You don't want your customers to open a ticket and tell you this is not working. You want to check
the slides will be online afterwards. So if you don't catch one of the URLs, they will all be in the slides.
Yeah, they will be with text to copy paste if you need any URLs. There's other security relevant headers you can set. These only work on HTTPS websites. The other ones work on HTTP as well. There's of course the HTTP strict transport security, which tells the browser, oh, you're here with a secure connection. Please don't use anything else. Come back with a secure connection for this amount of seconds in the future. And if you really know what you're doing, you can set your website to preload HSTS, which means there's a hard-coded, compiled-in list in your browser that tells the browser, always use HTTPS on these websites. And if the user explicitly types http:// rewrite it to HTTPS before sending the request, so you're already protected from the first request a browser makes to your site.
Do think about submitting your URL to that list. If it's on that list, it's not impossible, but it's really hard to get it off the list.
There's a process to get your website, your whole domain, including all subdomains and hosts you have probably only for internal users that don't use certificates. There's a way to get it off that list again. It involves submitting your list and answering a few questions to some Google executives, and also having a few 100 million users update their browser to get the new list. Which I don't see which part is the problem, but it's hard to get off that list. You forget about it. If you're on HSTS preload, you'll never get that back.
And of course, there's the other option, the HTTP public key pinning. That's even more interesting and
public key pinning means the web server tells the browser, these are the certificates you can expect to see on that website, and if you find anything else, even if it's a valid certificate by some governmental authority, please don't connect and tell the user. There's also no way to click through a connection. There's no, I know this, I know it's insecure, yeah, please advance, confirm this exception. You won't get that button. Your users will not be able to connect to that site anymore. With public key pinning, you can actually cryptographically take down your domain. If you do it wrong, if you don't have proper key management in place, this can really go badly. So it's interesting for high security sites to do this, but please test in advance before going that route.
Maybe with a domain that's not that sensitive, not with your main production domain, maybe.
Yeah, and think about hosts that are not exposed to the internet that would require valid certificates from that point on as well.
Test servers.
There's of course a nice generator for your public key pinning stuff. It's a simple shell script by Hanno Böck, who also does the SSL Labs newsletter by now and did a lot of interesting TLS stuff. Now we come to the part where you can test from the terminal.
So we got curl, of course, works with IP and legacy IP. So just give it a URL, and you get the headers and all the information you wanted to know. Of course, if you prefer the GNU userland over the BSD one, there's wget. Little bit more expressive syntax, but gets you the same results. Not as nice as curl, but still works quite fine.
Yeah. Of course, there's a lot of other testing options available. There's high-touch bridge. It won't give you a lot more details about your TLS setup on your web server.
But if you're in the banking industry and you have to comply with PCI DSS, this will give you a nice report. Looking rather similar to the ones we have seen before. So,
but if you need to be compliant with some things like these, you get the details if you're following PCI compliance in the current version.
Of course, that we talked about the servers. Of course, there's a TLS configuration and stuff like that in the browser. So you maybe want to check the browser settings. There's also a test for from SSL Labs that will show you the configuration, what your browser actually accepts in regards to ciphers and encryption and stuff like that, including SpeedyI and HTTP2 configuration. And of course, you can look into the configuration of each browser. So for Firefox, there's the BalCCon2k16 that will tell you a few things. Of course, you can change stuff in there, and you want to make sure that you're not changing something that actually breaks a lot of stuff. The same goes for Chromium, and for the Apple Vault.
Yeah, Apple knows best what's broken for you, so they don't let you change it.
So we got about 9 minutes left for the interesting part.
Yeah, web server configurations. Please take care of your backend servers. If you need TLS recommendations and config snippets that you can pretty much copy paste, you may have heard of the bettercrypto.org project. That does not only do web servers, but also VPN, email, and tons of other server things, and gives you crypto hardening recommendations for that. We're working on an update which takes into account TLS 1.3 and other stuff, of course.
But they have basically copy-paste ready samples of configuration with same defaults. Just think about your user base. Maybe they are still on old versions of an operating system with old browsers. So always test before rolling out into production.
And that guide, of course, is it's open source, it's free, it's libre, it's gratis. So you can check out every commit to that document that has ever been made from the first blank document. So
and if you have experience with one of the more exotic server variants, maybe you can even submit a configuration sample. They're taking in
pull requests. Yeah.
Pull requests.
Oh, so now coming to your favorite web server, Apache. It's your favorite?
No, it's not my favorite. I have to work with it. So,
okay.
So we're talking about on one hand on Apache. Yeah. Oh, okay. It's just the camera.
Oh, okay.
So Apache currently 2.4.23. Now I think that changed now. So 2.4 is the usual thing. One important note about the Apache HTTP server project. If you're installing Apache on Windows 95, 98, ME, or NT 4.0, please stop now. Thank you.
This is verbatim from the Mozilla documentation. So
Apache configuration.
Yeah.
Apache document.
Sorry, Apache. Yeah.
Yeah. So in order to implement TLS and the security headers we talked about, you need two additional modules. You need mod SSL and mod header. Yes, it's still called mod SSL, although we are using TLS and not SSL anymore. Get used to it. It won't change in the near future or even the far future, probably. Additionally, if you want to use HTTP2, there's also mod H2 enabled that, and you should have HTTP2 support in Apache. There's also, if you really want to, there's mod Speedy for older versions of Apache, but as Speedy is basically deprecated, stay with mod H2. So in Apache, as we know, it's a little bit more. Is this readable? It's a bad color. As we said, you get the slides. You have to enable the ports Apache has to listen to, and a lot of other stuff that Nginx, which we'll take a look at a little bit later on, actually does for you. And then for each virtual host that you actually want to cover, you have to turn the SSL engine on. You give it a certificate file, probably from
Let's Encrypt.
Let's Encrypt, and you disable the SSL 2 and SSL version 3. You probably can get away with disabling TLS 1.0 by now.
Yeah.
Yeah.
Especially for web hosts where you know your clients, like an intranet site that is connected from the internet, but you know your clients are on the current version. You can just go TLS 1.2 by now. And the
SSL cipher suite that is given here is actually a one-to-one copy from the bettercrypto.org project. So that usually works with all the available browsers. And of course, We want to enforce the cipher order we implemented on the server. We want to turn SSL compression off, otherwise we will get a rather bad rating at sslabs.com. And there's of course the DHE Diffie-Hellman ephemeral handshake thingy. For older Apache versions, you have to explicitly name it. With your newer version, it will auto-select matching DH parameters, but yeah, you still have to do that.
DHE ciphers are outphased by many browsers, so Chrome 53, I think, already completely disabled DHE cipher suite, so you can only use elliptic curve Diffie-Hellman ephemeral anymore. So if you're still on OpenSSL 098, that will be interesting because they won't have any matching ciphers anymore, unless you go RC4, but don't do that.
The security headers are a little bit easier. The syntax is the normal Apache server syntax. We won't go into the details. You can basically look it up in the slides afterwards.
You've already seen the headers. It's just the same, just with an Apache config line here.
And the same goes for CSP and X-Frame and all the other stuff. For redirecting, sorry, not redirecting, that's upgrading your client connections from HTTP to HTTPS. You basically want to send an 301 error, return code to your browsers. You have two options. You can either use mod rewrite or mod alias with Apache. Basically, both are doing the same thing. Performance-wise, there's not much of a difference. If you're using mod rewrite for other stuff, just do it that way. If you're not using mod rewrite, take mod alias. Of course, what we also had was the server tokens. So we want to hide the actual server versions and powered by PHP stuff and all the other things. So we want to turn that off. And if you're a fan of Terry Pratchett, you also maybe want to add the collects overheard headers for Terry Pratchett, which will bring us to the other web server.
The one other web server, yeah. all the pen testers in the room now hate us for turning off the server tokens because it's intelligence for them. Nginx 1.10.3 is the stable, and 1.11.3 is the mainline version that you can get. With Nginx, I got 3 minutes? Okay, yeah, that works. You gotta enable the HTTP SSL module. Same goes here. Of course, we're using TLS. It's a compile time option with Nginx. You got the HTTP v2 module, which deprecates the speedy module, so you can't use both unless you use a proprietary patch by Cloudflare. And since some of you may be Tor users, we won't use anything from Cloudflare. They won't let us use it anyway. With the server configuration, it looks a lot like the Apache one. If you're familiar with Nginx configuration, it's really easy. With the SSL protocols, you have to explicitly enable them instead of turning off the ones you don't like. For the cipher suites and the stuff, it just works the same. You need a certificate. And to get HTTP2, you just enter HTTP2 as a verb in the listen directive, and you will get HTTP2 support. Of course, we prefer the cipher servers to cipher suites to be given by the server and not let the client pick something. And Nginx also gives you a way to select Diffie-Hellman parameters if you don't want to go with the standard that probably has been pre-computed by some agency already. And with Nginx, you also get a way of selecting elliptic curve preference. There's only two you can actually use, which are implemented by all clients.
And you've got the speed hack, the speed buffer, the buffer.
Speed buffer.
The buffer size.
Oh yeah, buffer size. That's something that's only statically possible, but it gives you a reduced time to first byte, so your website will respond a little faster if you reduce the buffer size here to 4K. There should be, in an upcoming version, a dynamic way to size that window, which gives you even more speed. As for the security headers, you have already seen and heard about them. You can just add them with strict transport security and public key pinning. And for HTTP, of course, as well, you can use the content security policy and the X-frame, X-content type, and XSS policy headers. There's other headers you could look into if you know your website has a lot of Internet Explorer headers. There's a bunch of X headers you can set. Just check out if there's more that your specific website or user base can benefit from. Of course, for the upgrade to HTTPS, we send a 301 redirect. Just as simple as that. When redirecting, please don't redirect the user from your hostname to www.hostname and then to HTTPS and run then back to HTTPS without the W. You'll get 4 or 5 unnecessary redirects, which can cost a lot of time on a mobile connection. Don't do that. With the server tokens, you can turn them off with Nginx as well.
As you did with the light.
Yep, works just as well. Turn off the lights for the pen testers so they don't know which version you're running. And of course, Terry Pratchett is welcome on Nginx as well. So think about the headers. It's not the only thing you can do. They will not cover your pen testing of your actual web application. You can perfectly do a super secure SQL injection. If your backend really fucks up, that's still possible. If you're interested in web applications, they can augment your good TLS setup. Of course, mod security for Apache and Nginx, Naxi for Nginx only, with the slight downside that this is not fully compatible with HTTP 2 at this moment. It's being worked on, so in the near future, you should be able to use that.
So remember, if your SSL Labs report gives you an F,
your setup is on fire and you have to fix it. It's easy to remember. If there's something red, work on it. So everything less than an A grade is not acceptable anymore. Keep in mind, starting 2017, browsers will actually call out non-HTTPS websites with a big red not secure banner, and you don't want to be on that list. Which leaves us 3.5 minutes for questions. And we'll have a volunteer running around with a microphone.
So raise your hand if you're... This is for the stream and the record, for the recording. Yeah. No.
Oh, a microphone with the switch.
Yeah.
Hello. All right. I was wondering about Nginx.
Yeah.
About the upgrade in HTTPS. If there is any difference between sending a 301 or a rewrite, which is actually 302, I think.
301 is a permanent redirect and a 302 is a temporary redirect.
Is there any difference on the security side or on the performance side?
On the performance side, a 301 will actually be remembered by the browser for the session. So if you backtrack and go forward again, it will remember the 301 and not actually do the request and replace it before actually making that request. So that is a tiny round-trip performance gain. With a 302, you get a re-evaluation of that redirect every time.
And also it helps with Google indexing and SEO and stuff
there's
like that.
no security implications that I am aware of. So just a tiny performance issue and saving a few round trips. Any more questions?
On the dark side.
Come to the room. No. Where are the cookies?
So, as I know, Let's Encrypt, the script creates automatically HTTP setup for Apache. Should we trust it, or we should have a look on what's generated after we set up the certificates?
I personally would not trust any software that starts rewriting my Apache or other configurations just out of principle. My personal recommendation would be do your own setup and use one of the many HTTP Acme implementations that are available for Let's Encrypt, like let'sencrypt.sh, which you can find on GitHub, or there's acme.sh, I think. So the official Let's Encrypt Python client is a little strange in my regard. There's a lot of other really well-working implementations. So think about your TLS configuration and header setup for yourself and adapt it to your personal needs for your site, and use one of the very many options to have the refresh of the certificates automate. That really works well. I'm using that as well.
And in regards to configuration, you should always understand what you either generate, let somebody else generate, or copy from a website from somewhere else. You have to understand what it's doing before you paste it into the web server, especially for scripts that you're just piping through to executable.
Yeah, the usual curl pipe sh. Yeah, so danger lies ahead there. Any other questions? There's one.
This time is not the camera. So I just want to mention, I think that you had it on slides, but you didn't talk about it. When you're doing 301 for redirection from port 80, it's very common to forget that nowadays you got to look up for the IPv6 and IPv4, because there are systems that you just do redirects for IPv4 and forget about the IPv6, and you have the first MA record, and whoa, you have a hole. So your Nginx was nicely done on slides for IPv6, and Apache was, I think, as I saw it, only for the IPv4. No. I think that I saw it, but actually, for the guys here in Serbia, IPv6 is something that is not so much popular and implemented yet. But I have seen systems that are doing just the 301s only for IPv4, and you can access via IPv6 without any problem. So just keep in mind that you have to do both things, both on IPv4 and IPv6 addresses.
This is why we insisted on that you see the consistent setup for both protocols or across your cluster. The Apache example only goes for the host name, and depending on what it resolves to.
I don't see it.
Trust me, it's just for the host name, so depending on your A and Quad A records, it will just work with your support.
I didn't see it on the slide because
the font and the color is not.
It's a bad choice for that.
Sorry for that.
And regarding IPv6, Austria is the same, so
no, and it's IP, not IPv6.
It's IP, of course, because IP and legacy IP, there's an RFC for that. So, I guess we're
one last
quick one, very quick one.
Otherwise,
no quick ones.
Okay, das kannst noch hinten.
Well, thanks for your time.